In this problem, a game is played using one die. If a die is rolled, shows 1, the player wins 50 cents. If 2, the player wins $1. If 3, the player wins $2. If 4, the player wins $5. And if 5 and 6, the player wins nothing. If there is a charge of $1.50 to play the game, what is the game's expected value and what does this value mean? So we're going to make a table to make a list of the outcomes. Okay, so we have more cases. So I'm going to add more. So let's see if we have enough. The first one is going to be, the first column is the column of outcomes. And the outcomes, the die is rolled and showed the number 1. The die rolled showed number 2, number 3, number 4. Oh, we need more row. So I'm going to add another row here. Insert row below. So outcomes that come out to be 5 or 6. Okay. And the second column is about net gain or net loss. The person is charged $1.50 to play the game. So for any outcome, then I have to pay $1.50. $1.50. To pay, that means subtraction or negative side. And then if the die shows number 1, you win $50 or 50 cents. So gonna add by 0.5. Okay. The problem doesn't say like you get to keep $1.50. It looks like it's already collected. So then the net gain or loss for the outcomes that the die shows number 1 would be -1. If the die shows the number 2, the player wins $1, so we'll gain $1. So the net gain will be -0.5 for the second outcome. If the die shows the number 3, the player wins $2, so gonna gain $2 for this. And total gain, the net gain, gonna be -1.5 plus 2 or 0.5. The case that the die shows the number 4, the player wins $5, so add by $5 here. So the net gain will be $3.50. If the die shows either 5 or 6, win nothing. So that means the net loss is going to be 1.5 or -1.5. And the last column is going to be the probability of each outcome. Okay. A die has 6 sides, so the total outcomes of the sample space will be 6. If the side 1 shows, the probability is 1 out of 6. For the 2, going to be the same, going to be 1 out of 6, 1 out of 6, 1 out of 6. And then either 5 or 6 going to be 2 outcomes out of 6. To check whether you get the right probability or not, you can find the sum of all 5 numbers here. So 1/6 plus 1/6 plus 1/6 plus 1/6 plus 2/6. Yes, it comes out to be 6/6 or 1, which is the whole 100% chance. So it's good. So to find the expected value, we're going to have to include to add another column as the column of the product. Oops. Insert column to the right. And adjust it a little bit here. So that means the last column is going to be the column of the product of the net gain or loss. Gain or loss here multiplied by its probability. So we're gonna multiply -1 and 1 over 6 to get -1 over 6, -0.5 times 1 over 6, which is -0.5 over 6, 0.5 times 1 over 6 to be 0.5 over 6. Next one is 3.5 times 1 over 6, or 3.5 over 6. And then the last one is -1.5 times 2 over 6 becomes -3 over 6. So I keep all as the denominator 6, the same one. So then the expected value that we represent using the letter E is the sum of these 5 numbers. So mean -1 over 6 plus -0.5 over 6 plus 0.5 over 6 plus 3.5 over 6, and then plus -3 over 6. Since all of them have the same denominator, I just simplify the numerator as -1 minus 0.5 plus 0.5 plus 3.5 and then minus 3. And turns out to be the value -0.5 over 6, or is about -0.083 repeating, or keep 2 decimal places as the common way to round for the financial problem. So gonna be -0.08. And then how do we explain this number? The negative side represents the loss. So it means in the long run, explain it in the long run, the player can expect to lose about, lose mean negative side here. Okay, expect to lose about 8 cents for each game the player played.